Hello everyone, hope you're doing good and welcome back to our channel. Today we are at day 14 of the December daily Leetcode challenge, and today we have a medium level question in front of us. It's question number 2482, difference between ones and zeros in a row. Okay, this is the question. Take a minute to go through the question, and I will give the link of the question also in the description. Take a minute to go through it, and then we'll try to see how we can solve it. As usual, the first approach will be to try to solve it in the brute force way, and then we will try to see if we can optimize it further, right? So in on the basis of my way of saying, it should be easy question, and let us see if you feel the same. Okay, so we are given a matrix here. Basically, as you can see, we are given a grid here, which is a 2D matrix basically, and we also have to return a similar grid structure of same dimensions as given in the input. Okay, so we have given a zero index m cross and binary matrix. What is a binary? Binary means the content of the matrix will be zeros and ones only. Okay, that's what it is. So you see the left part of the matrix, see this left side matrix, and this will be the input given to us, and the right image which you are seeing here is the one which we have written. Okay, so how to arrive at this answer we'll just see now. So what they're saying is, see, these four statements refers to how to calculate number of zeros, number of ones in a row and in a column. Okay, that's what it is. Let's see. So they are saying the number of ones in the ith row is given by this. Okay, one row of I. Okay, just see here. One means number of ones. Row means in a row. Okay, in the ith row. That's what they are trying to say. And similarly, the number of zeros in the ith row is given by zeros of a row of I. Okay, and same for columns also. The number of ones in the jth column is given by ones of column of j. And similarly, the number of zeros in the jth column is given by zeros columns of j. Okay. Initially, even for me, it was like slightly difficult to understand what they are trying to say. But to just go through it, pause the video once and go through it. I am sure you will be able to understand what they're saying. Okay. It's very simple. They're simply calculating how many ones are there in each row and how many ones are there in each column. Similarly, for zeros, how many zeros are there in each row? This is the one, and how many zeros are there in each column. Okay, and yeah, we will be using them to get into our answer. Okay, now they're defining what is diff of I comma j. What is diff of I comma j? It means take the number of ones in the ith row, add it with the number of ones in the jth column, subtract it with number of zeros in the ith row, and subtract it with the number of zeros in the jth column. Okay, and this, see, as you can see, this difference is for ing. Okay, similarly, we have to do this for each of the rows, that is for each row and each column. Okay, and we have to return the matrix diff then. Okay, I'll show you initial calculation. You can go through these things as well, but let us try to see. I will try to make this video very short and concise. Okay, so please pause the video, try to remind it whenever you feel a doubt. Okay, so we'll try to trace it how we are getting this zero here. Okay, we'll just try to trace for this zero. What is the row number and column number for this? It is 0 comma 0. Okay, diff of 0 comma 0. First, what I will take is in the first row of this grid, how many ones are there? Okay, there are two ones, as you have mentioned. There are two ones. Okay, similarly, in the first column of this grid, how many ones are there? There is only one. Okay, this is one. Okay, now we need to subtract it with how many zeros are there in the first row. Okay, how many zeros are there in the first row? As you can see, this is the only zero. Okay, so there is only one zero in the first row. Similarly, how many zeros are there in the first column? There are two zeros, so we are subtracting it with two. Okay, now if you do this whole calculation, basically you will get an answer. Okay, that is zero. This zero will form the diff of 0 comma 0. Okay, that's what we have to do for every possible combination of rows and columns. Okay, that's what they're doing here. And then finally, you have to return this diff matrix. So by now, you would have understood that the dimension of the diff matrix is same as that of the dimension of the grid. Okay, we'll try to see how to do this in the brute force approach, and then we will try to see if we can optimize it further. And definitely, there is options of optimizing it. Okay, coming to the constraints given here, m and n are going to be, that is m and each of them can be up to the range of 1 to 10 power 5. Okay, so there will never be a case when m or n is 0. Okay, so you don't have to consider that edge case, right? So now coming to the solution, what I'm doing is, first of all, I'm taking I'm extracting the dimensions out of the grid. Okay, so in my case, n is going to be the number of columns. Okay, and similarly, m is going to be the number of rows. Okay, now as I said initially, I am first going to implement the brute force approach. Okay, and then we'll see how we can optimize it further. So the way they've defined, I'm taking the exact same way. Okay, I'm taking a row for one row. And see, once row means it will have, try to understand here, once row means it will try to count number of ones in each row. Okay, let me number of ones in each row. So how many rows are there? That is going to be the length of each column. Okay, that is going to be the number of columns. That is sorry, that is going to be the number of rows, right? So in this case, the number is m. Okay, so I am going to take it for m. Okay, that means this array is going to be of length m. Okay, same is the case of zeros row. Okay, what it will do is it will count number of zeros in each row. Okay, it is also going to be of length m. Okay, then comes the column ones. Okay, we have to count the number of ones in each column and number of zeros in each column. Okay, so how many columns we have? We have n columns, right? So this array will be uh, array of length n. Okay, same for this. This will be also of length n. Okay, initially all of them are initialized with zero, as you can see here. All of them are initialized with zero. Then I will go through each element of the array and I will try to fill in these elements. Okay, so I am going through each, you can say each row, and in that each row I'm going to through each of the elements. Okay, I am checking if grade of I comma j is one. Okay, that is that particular element is one. Then what I am doing, see if element is one, obviously it's going to be contributing to the that particular rows number of ones, and similarly that particular columns number of ones, right? That's what I'm doing here. I'm adding, I'm incrementing the number of ones in that particular row and number of ones in that particular column. Okay, if this is zero, by chance if this is zero, I have to come to the else part, and same thing I'm doing for else part also. I'm incrementing each of them by one. Okay, then I'm simply showing it here. Okay, just one of the columns, I'm just two of these I'm showing it here, just to understand if they're getting populated correctly or not, and this is not required in this case. And then I'm defining the diff column. Okay, as I mentioned, the diff column will be of same dimension as that of the grid column. Okay, so that's what I'm doing here. And finally, I'm trying to fill in the diff column. Okay, same loop the way you have seen here, exactly same loop I'm taking here, and then exactly the same following which they have mentioned, I'm doing it here. Okay, so diff of I comma j is equal to the number of one, that is the number of ones in the ith row, number of ones in the jth column subtracted by number of number of zeros in the ith row and the number of zeros in the jth column. Okay, exactly same way they have mentioned it here. Okay, and then finally we are returning the diff. I will just run and show you, and this solution works, right? As you can see, it's working. There is no brainer here actually. See, it's just a simple matrix question, and we do not need to apply any maths or anything knowledge here, any programming knowledge here. Okay, just simply dealing with matrix, right? In my way, this should have been an easier question, but wait, there are optimizations possible. This was a brute force approach. Now we'll try to see the optimized way. So while doing this, one thing that came to my mind is that, see, why should we calculate separately? See, there are only two cases, right? Either the element can be one or the element can be a zero, right? That's the else part, right? So just try to understand it. See, if I know, just focus on this example. Talk about the first row, right? If I know that the number of ones in a row is going to be two, then can I predict from that how many zeros are there? Obviously, right? The length of in this example, the row's length is 3, right? If out of those 3, 2 of them are 1, and obviously the left out element will be a 0. So how many zeros are there? The number of zeros is equal to the length of the row subtracted by the number of ones in that row, right? That is 3 minus 2, which is 1. That means the number of zeros in that particular row is going to be 1. So one thing is clear, that from the number of ones in a row, we can also predict how many zeros are that in that row. Okay, that means if I have this array, I can also predict this array, right? Similarly, if I have this array, I can also predict this array. Okay, this part is clear. Okay, we do not need the zeros ones. Okay, this one and this one we do not need. Okay, that's what we'll try to do in the next case. I will code and show you, right? Obviously, this part also not needed, and we will need a change here as well. Okay, so this brings us to the next solution. This one. Okay, as I mentioned, I've commented out the ones which are not required. I've removed this part. Okay, and I've removed this part. By the way, in Python, if you have to comment a particular column, there is a particular row, you'll have to use this hash symbol, right? Similarly, I've commented out this part as well. Okay, and obviously there, as I mentioned, there has to be a change in the calculation of diff as well. Okay, how should we calculate diff now? Previously, as you can see, it was number of zeros. Okay, number of zeros in the ith row. Okay, that we're replacing with n minus number of ones in that row. Okay, n minus number of ones in that ith row. Same is for the column ones as well. Okay, previously it was number of zeros in the jth column, that we're replacing with m minus number of ones in the jth column. Okay, remember the way you are placing, see, n has to come here and m has to come here. You cannot interchange them, right? Because see, it's nowhere mentioned that it's a like a perfect square matrix, right? It need not be a square. Okay, in none of the constraints they have mentioned that it can be a square, right? So you will have to be very careful while we are placing n and m. Okay, the way you have defined it, you should take it accordingly. Okay, the way I have defined it, in my case, m will come here. Okay, why n is coming here? See, n is going to be the yeah, the number of columns, right? number of columns, which basically means the length of a row, right? The length of a row. That's what I'm doing here. And minus one's number of ones in that row. Similarly, in this case, I'm just going to the number of rows. When I say the number of rows, it means the length of a single column, right? Same what I'm doing. I am minus number of ones in that particular column, right? And then I'm getting the answer. Let me quickly run and show you. Then we'll talk about the time and space complexity, right? So as you can see, it's getting accepted. You can submit and see by yourself. It's getting accepted, right? Coming to time and space complexity of it, okay. There's no brainer here. It's very simple actually. One thing is very clear that let's talk about the time complexity first. See, we are having two loops here, right? We are having two loops here for both the cases. Even for calculating the ones, even for calculating these things, okay, we require a for that is for loop inside a for loop. Again, we require a for loop inside a for loop for calculating the diff array, right? So definitely the time complexity is going to be O of m into n, okay, O of m into n. Now talk about the space complexity. Remember, whenever you're trying to calculate space complexity, you need not include the ones which are you need to see. For example, in this case, I need to return a diff matrix, okay. So you will say like a diff matrix will be again same as size of the grid matrix, that is m into n. So the space complexity will be O of m into n. No, that is not the case. See, this you have to compute because you need to return the result, okay. This is not when you are in a programming contest or in an interview, you need not include this, okay. You can clearly mention that you are assuming that the structures which you are going to return, that is the structure which you are going to build for the solution, because of the demand of the question, that need not be computer in the space complexity, because anyway that will be there, right? So excluding those things, that is excluding the grid matrix and the diff matrix, what is the space complexity? Obviously we'll have to take into consideration these things, okay. There is a single array of length m and there is a single array of length n, okay. These two are the only ones which are contributing to the space complexity for the solution, okay, excluding everything that is mandatory to include, okay. In that case, the space complexity in my solution go to be O of m into n, okay. If you are in interview, please talk with the interviewer, and you can safely assume, you can simply say that I'm assuming that I don't have to include those structures which are mandatory for the problem to solve, right? So the diff structure and the grid structure given in the problem, okay, these are the ones, the grid structure and the diff structure which you are calculating. This need not be included in the space complexity. If you remove them, these are the only ones which you are using two arrays of each of length m or n, okay. So this is going to be the space complexity of m plus n, and this is going to be the time complexity because we have for loop inside a for loop, okay. That's why it's of m into n. So this was the optimized solution. If you know any other solution, please do let me know. But just try to understand, if you the simple logic here was, if you have the number of ones in a row and you know the length of the row, then obviously you can calculate the number of zeros as well. That's what we are trying to implement it here, okay. So as I mentioned, I felt this should have been a easier question, but let me know your thoughts in the comments, right? That's all for today. See you tomorrow. Thanks a lot.